Good afternoon, everyone. We are the CityU team, and our proposed project is from RFM, Recycle Face Masks, to SGS, Sustainable Green Structural Concrete. First, we'll be highlighting the statistics and hazards of waste masks, then we'll be introducing our innovation and solution, and finally, our business plan.
So let's come to part 1, the statistics and hazard of waste masks. So nowadays, wearing masks to protect our health has become the new normal due to the epidemic. So it is inevitable that there is an increasement of the production and usage of face masks. So in fact, it was researched that the face mask increased to more than 9,000% in just the first 7 months of the epidemic. So how many masks did we throw away? In 2021 alone, we threw away about 3.4 billion face masks every day. So with Asia being the largest waste-producing continent, if we put these face masks into swimming pools, they could fill up more than 27 swimming pools by volume per day. In Hong Kong, we threw away about 4 to 5 million face masks every day, and 150,000 of them will enter the ocean. This would cause marine pollution and affect marine biodiversity. So how do we handle the waste masks now? Generally, three different methods are most widely used. Firstly, they'll be burned by incinerators, which would cause air pollution. And secondly, they'll be disposed by autoclaves, which would consume electricity and still need further treatment. And lastly, they may be discarded by landfill, which would be a waste of our land resources. So let's come to the part 2, our innovation and solution. So our proposed solution to deal with this issue is going to be to utilize the polypropylene fibers from recycled face masks to produce the sustainable green structural fiber reinforced concrete. This is also the first of its kind. A typical face mask will be made up of 3 layers, the outermost of which is made up of polypropylene fiber, which is the main thing we want to use. So as not all the components of the face mask can be used, the recycled face masks will go through a series of IoT smart recycling system, including collection, sterilization by UVC, separation, cleaning, sorting, and chopping. Our green concrete also involved the RFM fibers and recycled concrete aggregate. So to obtain to test the workability of our green concrete, we conducted some experiments to get some data.
So after curing the concrete samples for 28 days to ensure that it reaches its ultimate strength, we carried out compression and split tensile tests. So when we look into this graph as compared to conventional concrete, which is shown in the lowest points in both trend lines, the compressive strain shown in the red trend line and tensile strain shown in the green trend line both increased when we added 0.25% and 0.5% dosage of recycled face mask fibers into concrete. So this indicates that the addition of the recycled face mask fibers led to an increase in both compression and tensile strength of the concrete, improving its structural properties. Besides that, we can also anticipate other advantages. So the outer circle shown here refers to the properties of our green concrete. And since our green concrete is a type of polypropylene fiber reinforced concrete, we can anticipate it to have a higher cracking resistance, higher durability, and higher ductility, and also lower weight as compared to conventional concrete. Plus, it will also lower air pollution issues since it will lead to a reduction in carbon dioxide emissions, decreased uptake of landfills due to the reduction in face mask waste, and the reduction in construction and demolition waste because we will also incorporate recycled concrete aggregate in our concrete mix. And obviously, it is sustainable and green. Moving on to the business plan. So the market demand for green concrete is likely to increase in the future because there is an increase in the preference for environmentally friendly goods in the construction industry so as to reduce greenhouse gas emissions. And when our concrete can enter the market, it will be able to cater in residential building projects, commercial building projects, and other construction projects. So the time required to produce our concrete from recycled face masks would be around 5 to 6 months. The first month for collection and characterization of materials, the second month for mixed design and trial sample preparation, the third to fourth month for testing, specimen preparation and for curing, and lastly the fifth to sixth month for testing and result analysis. The estimated total cost per cubic meter of our concrete will be around 920 Hong Kong dollars. It is around 20% more costly as compared to conventional concrete since we are incorporating recycled face masks and also recycled concrete aggregate. But we are very confident that the many benefits of our concrete will definitely outweigh its cost. So we are aiming to operate as a nonprofit organization, and our potential funding sources will be through the government, construction companies, and non-construction large corporates. So as we are aiming to alleviate environmental issues and reduce burden on the future waste management systems, we will be aiming to receive funds through incentives like the Green Tech Fund. Other funds include the Construction Industry Council Fund, and construction companies may also fund our projects so as to achieve a higher revenue in return when they use green concrete in their projects. And lastly, non-construction corporates are also listed here as they may fund in our project to fulfill their corporate social responsibility needs. So to reiterate, if we apply 0.5% dosage of recycled face mask fiber reinforced concrete to a residential building with the need for 400 meter cube of concrete volume, we will be reducing more than 5,000 kilograms of carbon dioxide emissions, and around 1,800 kilograms of face masks will be recycled. So face masks will go from protecting your health to building green infrastructures, and that is the end of our sharing. Thank you.
Thank you. Thank you. So have you made a prototype with this SGS Concrete with those face mask materials? And if you have, those tested result is exactly what you show on the slide in terms of the benefits?
Yeah, so we carried out the experiment, like we created the green concrete and we carried out the compression test and the split tensile test. So that is our data.
So those, how you produce this concrete is from a factory, or this is you through a existing concrete production to produce this, or how do you do it?
We produce the concrete samples in our laboratory. We are expecting to get similar results.
So when you actually later on develop and also market your products, obviously you have to compare with the other products as well, even if you can prove the case. So how does it compare with the sort of other materials, other green concrete materials?
So there are different types of green concrete in the market. For example, one would be the recycled glass fiber reinforced concrete. But compared to that, the polypropylene fiber reinforced concrete, they show a better structural property. So that is the major advantage over the existing green concrete in the market.
Can you demonstrate that?
It is shown through our experimental results, structural properties, the increment in the structural properties, which is through the compressive strength increment and tensile strength increment.
Let me congratulate the team by coming up with this idea, use the fiberglass from disposed mass. In fact, I talked to your team before this session. Now, I think we'll talk about two types of problems here. Number one is the source of fiberglass, or source of material to provide reinforcement to the concrete. Then the next thing is the test you conducted are what we call purely concrete blocks, or a ginger, which is very, very different from the actual use of concrete in the construction world. Concrete are being used as reinforced concrete by use of steel rebars in between. So you might suggest that you continue your study with the real world concrete. Number two is, in the concrete standards, there are different grades of concrete, different strength. The strength you're doing in your lab right there, there's no calibration or standard grade, because I can see that you're doing on your own, not by a technician. There will be big variety in the outcome of the standard. That's number two. The third one is very interesting. In building safety, we have a lot of worry about the impact of fire on concrete crack, exposure of the rebar. That's why our tunnel nowadays, despite their thick concrete protection, we are fitted with thermal barriers on the outside of the concrete. So may I suggest you further study whether the fiberglass reinforced concrete at different grade, at different reinforcement, will have different fire rating. If you are successful, you will make Hong Kong fly.
Okay, very, very great advice.